Hi, this is the last video for gas laws. We are looking at a mixture of gases in this video. So it's the last gas law we have to learn. It's known as Dalton's law of partial pressures. And it's a pretty easy concept. So we've got a mixture of gases. The total pressure of all those gases combined is just equal to the sum of the individual pressures of each of the gases. So it looks like this, and so this is what is on your review sheet. P with that capital T here, that means the total pressure. Okay, so all you have to do is add all the pressures of the gases that are in this mixture together and you'll get the total pressure. And so we call these pressures of each individual gas the partial pressure because it's only part of the total. So don't let that word partial scare you. The one thing you just need to make sure of is make sure that all of these pressures are in the same unit. All right, well, let's just see what something like this looks like. So you have a mixture of gases. You have nitrogen dioxide, carbon dioxide, and sulfur dioxide. You've collected them. And the partial pressure of nitrogen dioxide is 1.25 atms. The pressure of CO2 is 2.64 atms, and the total pressure is 11.2. So the total pressure is 11.2 atms. All right, so 11.2 atmospheres is equal to what's from the nitrogen dioxide, 1.25 atmospheres, plus what comes from the carbon dioxide, which is 2.64 atm. So this is our partial pressure of NO2. And this is our partial pressure of CO2. And we want to know what is the partial pressure of SO2. All right, and so now it's just an algebra problem. So it's going to be 11.2, and notice atmosphere, 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 all the same unit, so good. Minus 1.25 minus 2.64, and we will get the partial pressure of SO2. And that answer is 7.31 atms. So if we added all these together, the 7.31, the 2.64, and the 1.25, they should all add up to a grand total pressure of 11.2 atms. Well, when do we use this? We use it if we collect a gas over water. And so if you remember back when we put the magnesium in some hydrochloric acid, I don't know if you remember this reaction. It's been a little while since we've done it. Magnesium in hydrochloric acid, we made hydrogen gas and magnesium chloride. This was a single replacement reaction. And we collected that gas in a eudiometer and we collected the gas over water. Well, that total pressure that we recorded was the pressure of the gas, but that water had a little bit of vapor pressure in it as well. So really that total pressure was the pressure of both the gas and water's vapor. So if we wanted to get just the gas's pressure, what we have to do is we have to take that total pressure and subtract from it the vapor pressure of water. And there are tables that give you the vapor pressure of water at all these different ranges of temperature. So anyway, just remember that if you ever are collecting a gas over water, really that gas was two gases. It was the gas and it was the water vapor pressure. And those two added together will equal your total pressure. So in a nutshell, when you're collecting gas over water, you must subtract the vapor pressure of water from the total pressure to get just the pressure of the gas. So here's an example of a problem like that. So hydrogen gas is collected over water at 24 degrees Celsius. The total pressure is 755 millimeters of mercury. And then it goes on to tell us that the vapor pressure of water, so the pressure of water at that temperature, is 22 millimeters of mercury. What is the partial pressure of the hydrogen gas? All right, remember that the total pressure is equal to the pressure of water plus the pressure of our gas. Alrighty, so our total pressure is 755 millimeters of mercury. The pressure of our water at this temperature is 22 millimeters of mercury. And what we want to know is the pressure of our gas, or the partial pressure of our gas. And when we do that, we are going to be subtracting 22 from 755, and we get that the partial pressure of our gas is 73 millimeters of mercury. Okay, so that is Dalton's law of partial pressures. So just remember, the total pressure of a mixture of gases is just the sum of all of the pressures of the individual gases. All right, we're going to practice this tomorrow. Bye.